Good day, ma'am. We are the group 3 and I will be reporting the laboratory 8, which is interfacing 4x4 matrix keypad with Raspberry Pi. So, introduction. 4x4 matrix membrane keypad is a slim input device, provides a useful human interface components for microcontroller projects. It is usually used to provide input value in a project. It has 16 buttons in total, which means it can provide 16 inputs values. The most interesting thing is it uses only 8 GPIO pins of a microcontroller, a 4x4 keypad membrane with the first 4 pins allotted to its rows, and the next 4 to the columns. They are arranged in a matrix-like manner to limit the number of pins and use a membrane switch under the hood. Convenient adhesive backing provides a simple way to mount the keypad in a variant of applications. It is usually used in applications such as security systems, menu selections, and data entry for embedded systems. In this activity, a 4x4 keypad matrix membrane is to be utilized as a system that can be used to connect and access communication with Raspberry Pi. The objectives of this laboratory is to successfully connect and access communication between the 4x4 matrix keypad and the Raspberry Pi. Second is to be able to get the user input with the use of a 4x4 matrix keypad. And the last one is to explore and create a simple circuit design consisting of a 4x4 matrix keypad and Raspberry Pi. For problem set, we have to create a program that displays in the LCD whatever statement entered by the user using the 4x4 matrix keypad. However, before the user is allowed to input any statements, a password must be passed first and to be entered using the 4x4 matrix keypad as well. The keypad pins to be used should be column pins equals 17, 15, 14, and 4. Row pins equals 24, 22, 27, and 18. You can choose any GPIO pins for interfacing LCD. Just be mindful of the pin number in the code. You can either use breadboard or PCB for interfacing LCD and keypad. Materials and equipment. We have Raspberry Pi 4 with Raspbian operating system installed and SD card. 4x4 matrix keypad. Resistors, 4 pieces, 470 ohms. LCD, 16 by 2. Jumper wires. Breadboard, this is optional but recommended. And PC or laptop or monitor display, and this is optional. Procedure 1. To begin, let's first prepare the hardware before moving on the programming phase. Start by assembling the components listed in the materials and equipment section. Now, let's proceed to connect the I2C 16 by 2 LCD display and the 4 by 4 matrix keypad to their respective GPIO pins on the Raspberry Pi using jumper wires. It's important to ensure that you connect the pins of the LCD display to the correct GPIO pins on the Raspberry Pi accurately. Do not connect it to the random GPIOs. Once the components are connected, you can move on the programming phase. Initially, connect all the essential cables, including the power source cable, HDMI cable for the video and audio, and the keyboard and mouse input cables. In order to fully operate the Raspberry Pi, allow a few seconds for the Raspberry Pi to boot up. After the boot up process is complete, the desktop interface will become visible. To proceed, click on the Raspberry Pi icon located on the upper left corner. Then click Programming, then click Thonny. Now, you will encounter the Thonny IDE interface. To proceed, click on File and select New to begin the program. Once you have completed coding your program, click the Run Current Script icon to execute it. So we have here the expected output of the program. This is the screenshot of the circuit diagram. So this is the codes that we use to run the program. So this one is the output. After run ng code, pwede na mag-input og passcode. First is i-try na to butangan og wrong password. Then press number sign para ma-enter. After pag-enter, mo-display ang incorrect password. Next is, itry nato ang pag-erase sa gipang input passive na sipyat o press sa number. So, i-press lang ang asterisk nga button dahil ma-erase tanan input so mo-display ang input cleared. Lastly, input ang 12345 which is ang sakto nga password. Press number sign para ma-enter. Mo-display dayon o correct password. For the results and discussion. First question. What are the necessary configurations you need to comply or libraries you need to install prior using the 4x4 matrix keypad? To successfully use a 4x4 matrix keypad with a Raspberry Pi, you need to configure the hardware by wiring the row and column pins of the keyboard to specific GPIO pins on the Raspberry Pi. Additionally, install the essential Python libraries using the commands smbus2, rplcd, and pad4pi. The SMBus2 library facilitates I2C communication required for interfacing with the I2C base LCD display, while RPLCD enables to control the LCD. The Pad4Pi library is utilized for handling keypad events, allowing you to capture user input effectively. Question number 2. How responsive is the 4x4 matrix keypad in terms of inputting data from the keyboard? The keypad is responsive, but you will have to wait for 1 second before you can press another number or letter, and sometimes the keypad do not register when pressed softly. Third question. What observations did you make while using 4x4 matrix keypad? Were there any challenges or unexpected results? As observed during the testing, there were no challenges or unexpected results encountered. Fourth question. Can you think of real-world application where a 4x4 matrix keypad could be useful? The 4x4 matrix keypad finds practical application in numerous real-world scenarios. It is commonly employed in security systems for entering passcodes, access control systems for secure entry, menu selection and embedded systems, data entry devices like POS terminals, industrial control panels for inputting commands, and automated vending machine for user interactions. Summary and conclusion. In this laboratory, the goal was to interface a 4x4 matrix keypad with the Raspberry Pi to enable user input and control. The keypad, with its matrix arrangement of 16 buttons, was successfully connected to Raspberry Pi using GPIO pins. The key pins were specified as follows: column pins 17, 15, 14, and 4, row pins 24, 22, 27, and 18. The program required users to input a password using the 4x4 matrix keypad before entering any statements. Upon successful password entry, users could input statements using the keypad, and the program displayed the entered statements on the LCD. The size of the LCD is 16 by 2. The keypad demonstrated the responsiveness, although there was a 1 second delay between inputs. Challenges such as soft presses not registering were observed occasionally. In real-world application, a 4x4 matrix keypad proves useful in security systems, access control, embedded systems for menu selection, data entry devices, industrial control panels, and automated vending machines. In conclusion, the project successfully achieved its objectives, providing a practical example of interfacing a 4x4 matrix keypad with a Raspberry Pi for user input. The code and circuit design can serve as a foundation for more complex projects involving input devices and control systems. The observation made during testing, including responsiveness and potential challenges, contribute to the comprehensive understanding of the keypad's behavior in a real-world context. And that would be all. Thank you for listening.